Good morning, this is your Stat Sensei, Mr. Spensei, and we're going to talk about cluster samples and stratified random samples. The previous video was talking about simple random and systematic. This one's going to be cluster and stratified. This will be a little bit longer just because students struggle more when they between these two. There's a little more confusion. So a cluster sample. To perform a cluster sample, the population needs to be broken into smaller groups. So we have groups in this case. Notice when we did simple random and when we did systematic, they weren't broken into groups. And the smaller groups are known as clusters. The clusters need to be small representations of the population. So each cluster should be a microcosm of the population. They should look pretty much the same. One group should look pretty much like the other group. But within each cluster, we're going to have differences, but each cluster should look pretty much the same. Cluster sampling tends to be difficult to perform with humans. For example, how would you divide your school, your high school, or Somerset High School into perform a cluster sample? Consider how you might divide the state of Texas or San Antonio into clusters so that every single group looks the same. And you sit there and go, well, by zip code, it's like, well, does one zip code look like the other zip code? Do they have the same amount of wealth? Do they have the same amount of farming? Do they have the same amount of large homes? And the answer is it's kind of very difficult to do that with humans. So you're going, well, if it's not useful for humans, why are we even talking about it? And the answer is cluster sampling is actually really important. And chances are you've either done it yourself, not knowing it, or it's been done to you. So being done to you, when they draw blood, they only need a small amount of blood drawn from you, and then they put that small sample under the microscope. And that small sample of blood under the microscope is a cluster because they're saying, hey, that small little amount represents all the blood in someone's body. Okay. And it should have healthy blood cells and unhealthy blood cells. And so that's how they track it. It's like, hey, it's got a mixture of everything in it. And regardless what sample they draw from you, it should have the same percentage of healthy and unhealthy. The one that you've probably done is you've probably done some baking. You've made cookies, cakes, or brownies. And you mix all the ingredients together thoroughly, and then you take a spoonful or taste it. Well, that spoonful has salt in it. It has sugar. It has flour. All right. It has cocoa or whatever it has in it. So it has everything in it that all the other batter has. And so because it represents the population and it has everything in it and you tasted all of it, then it's a cluster sample. All right. Soup is the same way. One spoonful of soup will tell you if it's good or not because it'll have the beef, it'll have the rice, it'll have the beans, it'll have it all mixed together and all the broth. And so one spoonful of soup contains everything. So again, that's another type of cluster sample. You know, Forrest Gump, he talks about life is like a box of chocolates. You never know what you're going to get because he knows that in the box of chocolate, you have all different types of chocolates in there. So if you perform the cluster sample, you randomly select a box of chocolates, and that box would represent that type of chocolate. And when you perform a cluster sample, this is the awesome thing about it, especially if you're talking about chocolates. Now, remember, to perform a cluster sample, you must perform a census within the group. In other words, if you're going to do a cluster sample, you have to sample, once you randomly select a cluster, you randomly select a group, then you have to taste all of it. So in the box of chocolates, it's like, you know what? I randomly selected one box that represents the population, and now I get to taste all the chocolate truffles in that box. How wonderful it is. All right. So, once again, I'm going to say it again. You randomly select the groups, and then you randomly select the cluster, and then you sample everything in that cluster. So what I did is I broke these into clusters, and let's take a look at the clusters when they were the way they were divided. All right. When we look at the clusters, like, hey, we have some big, we have some medium, we have some really small. And that's true for all 20 clusters. All right. And you go, well, why did you want 20? Because I wanted samples of size 5. And so all of these have 5 in it. And so then I went to the calculator and I went math, probability, random integer, 1 was my lowest value. I had 20 clusters and only needed 1, and I pressed enter. Well, it turns out I got cluster number 8. All right. And so I had to survey everything in cluster number 8. And in cluster number 8, I had one with 1, I had one with 4, another with 6, another with 10, and another with 16. When I added those up, I ended up with 37. And 37 divided by 5 is 7.4, which is pretty good because like I said, the actual true mean was 7.9. So we're about a 0.5 off. Okay. Once again, with a cluster, we randomly select the cluster and then we survey everything in that cluster. All right. The next one, the stratified sample. I'll be honest with you, if there's a favorite, if your teacher has a favorite, this is it. And I like the stratified sample because I know something. All right. So about it, and what I have to know is I need to be able to divide it into groups with common characteristics. So in this case, they're broken into strata based on common characteristics. With a cluster, they weren't on a common characteristic. They were broken into what was heterogeneous groups, where the groups looked like the population, but they had every element in it. Here, it's like, no, we're not going to have every element. We're going to have different types. Like we may have girls in one group and guys in another group. We may have babies in one group, teenagers in one group, young adults in another group, middle-aged in another group, and elderly in another group. We would have stratified based on age. All right. So we divide them into groups based on a common characteristics. Then we select a random sample from each group. All right. From each group, I'm going to select a random sample. All right. Though not required, typically the size of the random sample within this group are proportional to the group's size. All right. Generally proportional to the group's size. It's important to note strata are not determined randomly. The random part is the randomness is introduced through the selection within the strata. Once again, just like in a cluster, every individual has a chance of being selected, just like they did with the cluster. The cluster, we randomly selected the cluster. If we selected your cluster, you got sampled. If not, you weren't. Here, we go to each one of the strata, and you have a chance of being selected from that strata. Please note, there is no special case of the simple random sample. Although every individual has an equal chance, not every group has an equal chance. The only one that has every group is the simple random sample. So we take stratified samples for 2 important reasons. First, a stratified random sample allows us to ensure that each of the subgroups of interest within a population are represented. So each subgroup are represented. That might not happen with any of the others. All right. Secondly, we are able to isolate the impact of common characteristics that determine with the groups. Please note that unlike cluster samples, where each cluster is a microcosm of the population, the strata looks nothing like the population. It only has part of it. Cluster, each group looks like the population. In a stratified sample, the individual strata do not look like the population, but the sample will. All right. Dividing groups by gender is one of the most common ways to stratify, and we do this because we believe that in general there are differences in males and females. However, my go-to example for stratified sample is our high school. For instance, let's say we're trying to choose a theme song for the homecoming, and instead of performing a census and surveying everyone, we decide to survey the opinions of 100 students. We could do a simple random sample. However, we run the risk of choosing all freshmen. or all seniors. If we were to use a stratified sample, if we divided Somerset by grade level, freshman, sophomore, junior, and senior, and then did a random sample within each grade level, we would be assured of having every grade level represented. All right. And since we know 28% of the school is freshmen, maybe 28% of our sample is freshmen, and 26% are sophomores, and 23% are juniors, and 23% are seniors. All right. So we could proportionally do it by grade level. So let's take a look at our strata and see what I'm actually talking about. So on a strata, we're breaking it down by common characteristic. Well, if I ask you what the common characteristic is, you're like, oh, the really small, the medium small, the medium large, and the large. All right. So we see that they're broken down, they're put together in groups. All right. And within each group, I need to take a random selection. Well, in this case, each group had 20. And we have 5 strata. So I'll go to this group and I'll select one. This group, I'll select one. This one, I'll select one. Now I need to do that randomly. So what I will do is I'll take my calculator and I'll go math, arrow over to probability, random integer. Each group has 20 in it. And I only need, in this case, one value. And I press enter. And I got a value. In this case, I got 17. Then I did it again and I got number 8. Then I did it again and I got number 18. I did it again. I got a second 18, which was a surprise. And then on the last one, I got number 14. This one was a size 2, a size 4, a size 8, a size 9, and this one had a size 18. When I added those up, I ended up with 41, and 41 divided by 5 is 8.2. So basically, not exact, but pretty close to 7.9. And I employed randomness. So every single one had an equal chance of being selected at the beginning, but not every group. Again, we broke it into groups based on a common characteristic. In this case, our common characteristic was size, and then we randomly selected within each group. Now, I know that people struggle with the difference between cluster and stratified. So I have this little example I like to use. If I had a population, a giant population, and all it was comprised of was A, B, C, D, and E. That's everything in the population. Well, I can show the example of what stratified and what cluster would look like. Well, cluster, every single group would need to look like the population. So in this case, A, B, C, D, E would represent cluster 1. A, B, C, D, E look like cluster 2 because it has every single element of, and this would be cluster 3. Each cluster has every element of the population. All right. So I have it broken down into clusters this way. Now I would randomly select one of the 5 clusters. Let's just say I selected cluster 3. If I selected cluster 3, then I'd go survey A, survey B, survey C, survey D, and survey E. So that would be a cluster sample. On the other hand, if it were a stratified sample, it'd be broken down by category type. Well, I have a category of A's, so that would be strata 1. Then I have a category of B's, and that's strata 2. Category of C's, strata 3. Strata 4. And this would be strata 5. Then I'd randomly select it from each strata. Now let's say I selected this one, so I'd survey that A. Then from the B's, I selected this one. Then from the C's, I selected this one. From the D's, I selected this one. And from the E's, I randomly selected that one. Again, I randomly select within each group. So the strata has all A's, all B's, all C's, all D's, all E's, but my sample still had an A, B, C, D, and E. The cluster, each cluster had all the letters in it. So that's kind of the difference. So, couple things, keywords, cluster, you break it into groups, randomly select, and survey all. And survey all in the group is the key word, the key phrase. If it's survey all, probably a cluster. With the strata, you break it into groups and randomly select within each group. All right, cluster, break it into groups, and then randomly select and survey all within the group. All right, I hope that helps. Appreciate you watching. I hope to see you on the next one. Thank you.